This lesson is an introduction to the concept of object-relational mapping, which will kind of allow us to have a framework for storing objects within relational databases and translating between these two different worlds and the different ways that they organize and store data. And this lesson is going to be presented in a language agnostic way. So the concepts here apply to different frameworks and different languages. And in particular, they will apply specifically to Java and C# frameworks. And so the syntax will not be exactly related to a specific language. You should just focus on the concepts as they relate to objects and relational databases. So what is ORM, or Object Relational Mapping? Object Relational Mapping is a technique for storing, retrieving, updating, and deleting from a database within an object-oriented program, and specifically within a relational database. There are different models for databases and different ways you can store data. One of the most common is that of a relational database, and that's what we've worked with previously in this class and will continue to work with. ORM systems utilize what's often referred to as a data layer that will exist between your model classes and the database and will manage the translation between these two worlds. And we'll look at exactly what the differences between those two worlds are and why we need a data layer to manage that translation for us in just a moment. And the data layer is typically a library that is written in the specific object-oriented language like Java or C#, and that is part of or works in conjunction with the web framework that you're using to write the rest of your application. So let's look at an example from the program that we've been working with in the last several lessons. So we can think about data and the way it's stored in two different ways if we're looking at storing stuff in a database. On the left-hand side, we have a perspective from the object or class side where we have a simple class diagram. And here we've only included a few of the properties we've been working with just to keep things nice and simple. If we have a cheese class, we might have an ID that's an integer, a name that's a string, and a description that's also a string. And those things would be organized in the way that we've seen objects and classes organize data. On the relational side, we've seen previously that relational databases will organize things in tables. And so in particular, a table has rows and columns. So I might think about my cheeses as being stored in a cheeses table with 3 columns, an ID column, a name column, and a description column. Each of those do have data types associated with them too that are specific to the database engine. So there are concepts that relate to things like integer and string. They'll typically be called int or varchar. And that's not too important for us right now, but there are data types associated with those columns. And then data is stored within those tables as rows. Okay, so this is the model and the structure of data in the object world and in the relational world. And you can see how those are kind of slightly different. Let's look at what an actual piece of data would look like. On the left-hand side here, the bottom left, we have this kind of loose diagram we've often drawn with an object as a circle or a blob, a round thing. This is a concrete object that you would have within your program, within the computer's memory. And so it has specific values for the properties that are associated with the given class. In particular, there are specific ID, name, and description values for that particular object. If we were to try to store the same type of data in the relational world on the right-hand side within a SQL database, we would put each of those values within a specific row in the associated columns, right? So kind of a very logical mapping from one side to the other. We can see how in a database the data looks when it might be structured the way we've normally looked at it on the left-hand side within objects and classes inside of our applications. So there are some operations that we'll have to be able to carry out in order to work with databases within our application. And so in general, we want to be able to take the objects that we have and then to put them in a database, and so we can retrieve them later. And so the first thing we want to do is saving. So this is often referred to as creating in the database world. There's an acronym CRUD, create, read, update, delete. Those are the 4 major database operations that you will carry out. So saving or creating is the primary one. Okay, and so we're just going to envision our data layer here. Recall that our data layer is going to handle the object to relational mapping for us. So it's going to sit in the middle between our relational database and our object-oriented program. And so if I want to save an object, I have the same object from the previous slide here. I can, within my application, my data layer will give me a method or a mechanism to, say, call save, a method or something similar to that within the data layer. I can pass that object into the data layer and ask it to save it for me. And that's really all the work we're going to have to do once we set up this machinery, is create an object and hand it to the data layer and ask it to save it for us. On the other side, though, the data layer will know exactly what that means in terms of a relational database. So it will insert a row. Insert is the SQL command to insert a new row into a table, and it will know exactly what table we're talking about based on the type of object that we hand it, and it will know exactly which properties of that object go into which columns, and it will handle that insertion for us. And so the data layer really is going to do a lot of that work that would otherwise be very manual and repetitious. On the other side, if we want to get data out of the database using an ORM system, the data layer is going to allow us to do that as well. So when we're asking for data from a relational database, that's usually framed as a select statement. We would select some row or rows from the database given certain criteria. So we can select a given row from our cheeses table. The data layer will then create a new object of type cheese and populate the given properties for us. So in particular, that means explicitly calling the new, calling the constructor on the given class, and then setting the specific properties, and then giving our program that specific object that was created. So for all intents and purposes, within our code, we're never going to see things on the right-hand side of the data layer. We'll only see things on the left-hand side, but we need to understand the magic. Well, it's not really magic, but sort of the various operations that are happening behind the scenes and are being done for us by the object relational mapping system, or the data layer. And things here can get pretty complicated. This example we just saw so far, you could probably write the code to do that yourself, to take a simple object with, say, int and string fields, and to insert that in a table within a database. So if we showed you how to connect to a database directly and to make queries, you could do that on your own. However, things get pretty complicated pretty quickly when we're working with relationships between objects and relationships between data in different tables. In particular, we're going to, in a lesson shortly, we're going to introduce the idea of a category, and we'll have a new class that will represent the category of a cheese, and we'll be able to put different cheeses in the category. So each cheese will have its own category property. And we know that when we're looking at relationships between objects, those are stored or viewed as references, rather. So the category property of a given cheese will be a reference to a category object, and we viewed those as being arrows or pointers. So in particular, in this example, I have two different cheese objects that have the same category, and rather than having two different objects, they point to or reference the same object, which is the one on the right there. Okay, and so those objects are related to each other in this relational way within our object-oriented programs. So if we want to think about how this data might be stored in a relational way, things become a little bit more tricky, right? So we can probably pretty easily find a way to structure our data as it relates to the category class. And in particular, we only have two properties within that category class. We have a name and an ID, and so we saw in the last slide that storing something as simple as that is just going to have two columns, one with each associated with each property, and we can just insert the data right there, right? This ID field is what's called a primary key. And so we've been using IDs within our object-oriented programs, and we framed it as a way to tell our objects apart, right? So it was an easy way for us to give a unique ID, a unique numeric identifier to objects so that we could tell them apart very easily. And the same holds true in the relational world. So every table you should have a primary key. And for us, primary keys are almost always going to be an ID column that has a unique integer. Any two rows within that table will have different ID values. Okay, primary keys can be more general. They don't have to be numeric. They don't have to be a single column. But for us, they generally will be. And this notion of a primary key is going to be what allows us to relate data in the relational world into the same way that we did in the object-oriented world using references. So in particular, we can, if we want to store this relationship between cheese objects and category objects, we can add a category ID column to our cheese table. And so this will allow us to store the unique ID associated with the category that is referenced on the left in the object-oriented world, and we can store that ID in the category ID column within the cheese table. And so the database will then be able to properly reference these things for us when we want to get them out. The data layer will be able to do that rather. And so we also have a primary key within our cheeses table. We didn't call it that before, but that's exactly what it was. This category ID column that is holding a reference to a primary key in another table, it's holding the value of a primary key in another table, is what's called a foreign key. So category ID in the cheeses table is a foreign key to the categories table. And when our database engine is going to, when we're going to be working with that and getting data out of the database, we will use what's called a join query to select the right types of data and put those together, and then to reconstitute our objects on the left-hand side. But the data layer is going to handle that for us. But we just need to know that we need to have a picture of how these things are stored on the right-hand side in the relational world. And so that's just a very brief introduction to how relational data relates to object-oriented data and what's happening when we're using these ORM tools to translate from one to the other. And so we'll point out some of these things and see how some of these concepts specifically relate to the examples and the code that we're working with as we go.